Everybody, welcome. This is Angie with Angie's Beyond the Lecture. Today's question is going to cover Hess's Law and the formation of ammonia. And basically in these situations here, you need to determine the overall enthalpy change or delta H of a reaction based on the individual steps to get there. And so in just a moment, we'll cover what Hess's law generally entails and how we get to the final answer. And before we dive right in, my name is Angie again. I'm with Angie's Beyond the Lecture. I've been a STEM tutor for nearly 2 decades, and that includes working with high school and college students. In fact, I was a staff tutor with Collin College just north of Dallas for about 5 years. So glad to be here. Thanks for joining me. Now I'm going to take a little tour down this worksheet here. This is just one question, single question worksheet, and you'll see the answers here. I am going to write them above. And to tie this all in here with Hess's law, what we're saying, or what Hess said, is the overall enthalpy change, or the delta H, of a reaction is determined by summing the enthalpy changes of the individual steps. So notice we have 2 equations we'll need to manipulate and add together to get the overall delta H. And then we just add here, enthalpy is a state function. The total H depends only on initial and a final state, not the actual pathway taken. So we know it's pathway independent. We'll talk about those types of, sorry, just need to adjust my microphone here. We'll be talking about these types of functions in both chemistry, and you see that in physics as well. But back to the question at hand here, we're going to look at a couple of individual equations. Now notice they have their own delta H's tied to them. And all we need to do is look at these equations and say, okay, well, first, could we add them together and get our final goal equation of the formation of ammonia, given some nitrogen and hydrogen gas to form the NH3? The answer is no, because obviously you should see that we have multiple species in there that don't belong, right? I don't see oxygen, I don't see water in the overall, or, the overall equation. So we need to look at eliminating those. And typically how that happens is you have the same amount on both the left and the right hand side when you add them together, and you can just cancel them. So just like algebra. So if I have, for instance, 3 plus x equals 3 plus y, we know in algebra, if we subtract 3 from both sides, they're gone, right? They're equivalent statements. So here we would say x equals y. And then in Hess's world, we would just, be left with whatever compounds are remaining, or species are remaining in this particular setup. So anyway, it all ties back to algebra a lot of the time. So now we need to look at these equations 1 and 2 individually to see how we can manipulate them so we can add them together and get that goal equation of the formation of ammonia. Now, whatever we do to the equation, we have to replicate that with the delta H. So for instance, if I cut everything in half to suit my purposes to solve for this, I would need to cut delta H in half. If I need to double the reaction quantities, you double the delta H. Okay, so it's a mirrored action or event on both sides. Now I'm going to erase the markings that I did. There we are. And the first thing I see, I want ammonia over on the right. So I'm probably going to flip, looking ahead, I'm probably going to flip equation 1. Also note, I need 3 hydrogen molecules and I only have 2. So I definitely know I need to multiply equation 2 by 3 halves. Remember, to get, if we have 2 and we multiply by 3 over 2, I get 3. That is kind of wonky, right? But you'll see it'll work out. So I'm going to start with equation 2. I'll just apply that across the board. I'm going to drop the states of matter for this just to save time to H2O. Okay. So if we apply 3 halves across the board, I'll have 3 H2s. I'll have three waters, okay? And when we take that second delta H, we'll just might as well as 3, okay. Let's take our calculator and see what we end up with. 571.6 times 3 over 2. So we have 857, negative 857.4 kilojoules. Okay. And when we're done at the end, we'll just add all those delta H's together, the ones that are relevant. Okay. I think I'm in a good spot for number 2. When I go back to equation 1, notice, yeah, we do indeed need to flip and then probably just cut everything in half. Notice we only need 2 ammonias on the right over here, and I have 4. So what I'm going to do is I'm going to flip and then cut in half. Equation 1. So flip, I'll do that first. It doesn't matter. Remember, this is additive, and order really shouldn't matter when it comes down to it. So I'm going to go ahead and flip number 1 and say, okay, now we have 6 waters plus 2 nitrogens to get 4 NH3s and 3 O2s. And so delta H here would just end up being 1530 kilojoules. Okay. Okay. And then notice I just flipped the sign. So we're saying that this reaction here, the new one with the 6 waters and 2 nitrogen molecules on the left, that is endothermic. I'll add the positive sign just to be clear. And then now I'm going to divide by 2. Or times by half. So I'll have, oops, not mean to ask Sari something there. Okay. Actually, I'm going to word this as times 1/2. Okay. Give me a moment while I write this out. NH3. Okay. So if we apply a half, if we cut everything in half across the board, we'll have 3 waters, 1 nitrogen, which is what we want on the reactant side, and we'll have 2 ammonia. Okay. And we would need to end up cutting that 1530 in half. So if we just bring down that quantity, it's positive 1530. So whatever half of 1530 is. 765. 765 is half of 1530. Okay. All right. So we're basically dealing with, so far, if we were to add these two together, right, which I'm thinking will be able to eliminate the waters and oxygens, and then we would, in essence, add these two together to get the final answer for our delta H. But let's test the theory. I look at this, I need to rewrite it on the bottom and then show cancellation. And then as long as we confirm we get the correct formation of ammonia based on the equation we need, we're good to go. All right, so 3 H2s and 3 halves of an oxygen molecule to get 3 waters. I'll just put here add and add those two. Okay, and then we're going to have 3 H2Os plus an N2 to get 2 ammonias. Yeah, and I'm already seeing like things will cancel. We'll cancel water, water, and the 2 oxygens. So notice 3 waters on each side, gone. 3 halves of oxygen on each side, gone. And then we're left with 3 I believe these are all gas. Yeah. I don't worry too much about states of matter unless you're dealing with a system where you might have gaseous water and liquid water. And then you definitely have to watch your states of matter here. I'll just add these at the very end. These are all gas. Okay. And this means, I'll switch back to green. So this means we just need to find delta H is going to be, I covered that number up, negative 857.4. Gosh, sorry, I'm struggling with my handwriting here. 857.4, and we'll add 765. So we're definitely going to be a little bit negative. Negative 857. I'm just going over to the TI, like negative 92.4. Negative 92.4. That's our final answer on delta H. Okay. And I'm just going to show anyone who's watching this, yeah, step 1. I just broke out each step. Step 2, step 3, step 4. So notice I multiplied the equation 2 by 3 halves. I went ahead and divided the first one by 2. Yeah, and then flipped it. I think in the video I flipped it and then cut it in half. Notice here on the answer key, I cut it in half and flipped it. But again, order doesn't matter. We get to the same answer. And notice, and when you add the equations together, yes, I highlighted the equations in yellow and the delta H's in blue for clarity. Yep. And then everything cancels out. You're left with negative 2.4 kilojoules. There's your Hess's Law again. Now, again, thank you for watching this video. I'll be putting out content on a regular basis. And thanks again for joining me. Again, like and subscribe if you want to see daily questions on the community tab. I have those out there pretty much every day. Those cover chemistry and geometry at the moment, and I'll be adding physics and additional STEM subjects soon. Thanks again for joining me.